Hello, this is the visual abstract of study on microstructure, hardness and optimization of wear characteristics of Aluminium 6061 reinforced TiB2 CeO2 hot-rolled MMCs using Taguchi method. Abstract. In the present investigation, Aluminium 6061 has been used as a base material. TiB2 and CeO2 has been used as a reinforcement particulates. Stircasting method was implemented to develop the hybrid Metal Matrix composites. The developed hybrid Metal Matrix composites were undergone to the hot rolled process at the temperature of 515 degree centigrade. The mechanical properties such as hardness was evaluated by using Vickers hardness test equipment. The wear behavior of the developed hybrid Metal Matrix composites were evaluated by using pin on disc wear test equipment. Here, Taguchi techniques was implemented for the evaluation of wear behavior by using L27 orthogonal array. The wear fractography tests was evaluated to study the internal fracture surface of the specimens. The figure shows the microstructural study of the base material, hybrid composites, and hot rolled hybrid composites. By the microstructural study, it is easily observed that uniform distribution of particulates has been taken places. The figure shows the hardness output of the developed base material and hybrid composites. It shows that by increasing the weight percentage of reinforcement, the hardness of the developed composites has been enhanced. The table shows the selected process parameter with their levels to optimize the wear behavior of the developed composites. The table 3 and table 4 shows the ANOVA outcomes for the wear loss and COF. By the outcomes, it is observed that TiB2 is the major contributing parameter with having 53.14% in wear loss and 62.41% in COF. Figure 3 and figure 4 shows the effect of varying parameter in terms of graphical representation. The figure shows that by increasing the weight percentage of reinforcement such as TiB2, the wear loss has been reduced, whereas by increasing the load and sliding distance, the wear loss has been increased. The same way, the figure 4 shows that by increasing the weight percentage of TiB2, COF has been increased, whereas by increasing the load and sliding distance, COF of the developed composite has been reduced. Table 7 shows the optimal process parameters for the confirmatory test trials of wear loss and COF for the developed hybrid Metal Matrix composites. Table 8 shows the confirmatory outcomes for the wear loss and COF of the developed hybrid Metal Matrix composites. By the outcomes, it is observed that the error difference of orthogonal experiments outcomes and confirmatory experimental outcomes was 5% for wear loss, and error difference of orthogonal experimental outcomes and confirmatory experimental outcomes was 6.25% for COF, whereas 5% and 6.25% was within the acceptable limit. Figure 11 shows the semi-fractography of base material and hot rolled hybrid composites. By the image, it can be easily observed that particle agglomeration and deep grooves as present in the surface of the worn out surfaces. This is due to the presence of hard particulates. Figure 12 shows the EDS analysis of the developed hybrid Metal Matrix composites. From the image, it can be easily observed that the presence of Ti and Ce. The presence of Ti and Ce shows the presence of TiB2 and CeO2 particulates within the matrix. Conclusions. Stircasting method was successfully used to fabricate the TiB2 CeO2 reinforced Al6061 composites. Hardness of the developed hybrid composites was enhanced by addition of reinforcement content. Taguchi optimization method was implemented to examine the wear rate of the developed hybrid composites. The outcomes of the conformation test result shows that maximum of 6.25% of error was observed in COF and 5% of error was observed in the wear loss. It can be concluded that it was within the acceptable limits. From this analysis, it was concluded that less fracture initiation was seen in the hot-rolled hybrid MMCs. The EDS study shows that Ti and Ce peaks. It is the evidence of the successful incorporation of TiB2 and CeO2 particulates in the developed hybrid Metal Matrix composites. Thank you.